Hello students, welcome to my channel Dilip Padhi Official. Today we start with another new topic, that is Newton's second law of motion. In the last class, in the last video, we have discussed broadly about the Newton's laws of motion. In this class, we will discuss Newton's second law of motion. Before we study the Newton's second law of motion, we have to know a new term which is a very important physical quantity, that is momentum. What is momentum? It is very important physical quantity. It is denoted by P and it measures the amount of motion contained in the body. It measures amount of motion contained in a body. And how can we measure the amount of motion? It is equal to the product of mass and velocity. That means momentum P is equal to mass m into velocity v. Momentum is equal to mass into velocity. Product of mass and velocity is equal to momentum. And it is a vector quantity. That means it has both magnitude and direction. Now, we will explain an example. If we will take two balls of same size, a plastic ball and an iron ball. If we throw both the ball towards a sand hill with same speed, with same velocity, then plastic ball causes very little damage to the sand hill. But iron ball causes a greater damage to the sand hill. Though both the balls throw with same velocity, as the iron ball has larger mass, it causes greater damage, whereas a plastic ball which has a smaller mass causes lesser damage. That means momentum of the body with small mass is lesser than momentum of the body with larger mass, both having same velocity. On the other hand, if we take two similar plastic balls and both the balls will throw different velocities, one ball we throw with large velocities and other ball we throw with small velocity, then the ball which we throw with larger velocity causes greater damage to the sand hill. That means both velocity and mass combinedly affect the sand hill. They are combinedly responsible. So, this is the momentum. that means product of mass and velocity is called momentum, and it is vector quantity. Its SI unit is kg meter per second, or we can write kg meter per second. Now you are clear about the momentum. Now we will discuss second law of motion. Newton's second law of motion. What does the Newton's second law of motion state? Newton's second law of motion states that the rate of change in momentum, the rate of change in momentum is directly proportional to the applied force. The rate of change in momentum is directly proportional to the applied force. And the direction of momentum is same as the direction of net force. Direction of net force means resultant force. The law states that the rate of change in momentum is directly proportional to the net force applied. Also, the direction of the momentum is same as the direction of net force. The direction of momentum is same as the direction of net force or resultant force. This is the second law. How can we explain with mathematically? Let us see. Let a body of mass m m is moving with an initial velocity of u. A body has mass m and its velocity is u. A constant force F is applied on it. A constant force F is applied on the body for time t. In this time period, the velocity of the body changes to v, and the velocity of the body changes to v. Now you see, what is the mass of body? Mass m. What is the initial velocity? Initial velocity is u. What is final velocity? V, and time is t. These are given. We have to calculate the initial momentum, final momentum, and rate of change in momentum. What will be initial momentum? Initial momentum. Let us take P1. Mass is m and velocity is u. Because product of mass and velocity is momentum. Initial momentum is u, initial velocity is u. So initial momentum is mu. What is final momentum? P2 is equal to mass into final velocity, mv. Change in momentum, P2 minus P1, final minus initial, that is mv minus mu. Rate of change in momentum. I will erase the above written things. Now, initial momentum P1 equal to mu, final momentum P2 equal to mv, and change in momentum P2 minus P1 equal to mv minus mu. Now, what will be the rate of change in momentum? Rate of change in momentum means change in momentum by time. Change in momentum by time. That is equal to P2 minus P1 by t, or mv minus mu by t. P2 equal to mv, P1 equal to mu, P2 minus P1 equal to mv minus mu, time is t. But Newton's second law of motion states this rate of change in momentum is directly proportional to the applied force. That implies force applied is proportional to rate of change in momentum. Rate of change in momentum, or F proportional to what is the rate of change in momentum? mv minus mu by t. We can write F equal to k mv minus mu by t, where k is the constant of proportionality. K is constant. If k equal to 1, then F is equal to mv minus mu by t. If we take common m into v minus u by t. But we know rate of change in velocity is called acceleration. Final velocity minus initial velocity by time is acceleration. So v minus u by t equal to a. We can put a instead of v minus u by t. Therefore, now we get F equal to ma. This is the relation between force, mass, and acceleration. That means acceleration produced in the body is directly proportional to the applied force and inversely proportional to the mass. Or we can write it A is equal to F by m, or A is proportional to F, or A is inversely proportional to mass. That means acceleration produced in a body is directly proportional to the applied force and inversely proportional to the mass of the body. If force is more, then acceleration will be more, and vice versa. If mass is more, then acceleration will be lesser. This is the second law of motion. And how can we derive the force relation between force, mass, and acceleration? Now we will discuss the unit of force. SI unit of force is Newton and CGS unit of force is dyne. What is 1 Newton and what is dyne? We will discuss. SI unit of force is Newton and CGS unit is dyne. SI unit is Newton, CGS unit is dyne. What is 1 Newton force? Let a mass is given 1 kg. A force is applied on it, by which the acceleration produced in the body is 1 meter per second square. Then that force is called 1 Newton. That means the force which produces an acceleration of 1 meter per second square on a body of mass 1 kg, then that force is called 1 Newton. The force which produce an acceleration of 1 meter per second square on a body of mass 1 kg is called 1 Newton. That means the magnitude of force is said to be 1 Newton if this force produces an acceleration of 1 meter per second square on a body of mass 1 kg. Therefore, 1 Newton equal to 1 kg into 1 meter per second square, or 1 Newton equal to 1 kg meter per second square. That means Newton is equal to kg meter per second square. Similarly, what is 1 dyne force? The force which produce an acceleration of 1 cm per second square on a body of mass 1 kg is called 1 dyne. Therefore, 1 dyne is equal to 1 gram, mass 1 gram. The force which produces an acceleration of 1 centimeter per second square on a body of mass 1 gram, not 1 kg, is called 1 dyne. 1 gram into 1 cm per second square, or 1 gram cm per second square. That means dyne is equal to gram cm per second square. Newton equal to kg meter per second square. Dyne equal to gram cm per second square. Now we will see what is the relation between Newton and dyne. Relation between Newton and dyne. 1 Newton equal to, we get 1 kg into 1 meter per second square. 1 kg equal to 10 to the power 3 gram or 1000 gram. 1 meter per second square means 100 cm per second square. 1000 to 100. Here 3 zeros, here 2 zeros. 10 to the power 5 gram cm per second square. Gram cm per second square equal to dyne. That is 10 to the power 5 dyne. Therefore, 1 Newton is equal to 10 to the power 5 dyne. This is the relation between Newton and dyne. Now, gravitational SI unit of force is kgf. And CGS unit is GF. What is kgf? Kilogram force. GF means gram force. What is 1 kgf? 1 kgf means the force of gravity acting on the body of mass 1 kg. The force of gravity acting on a body of mass 1 kg is called 1 kgf. That means 1 kgf is equal to 1 kg and the acceleration produced by the force of gravity of Earth is 9.8 meter per second square. 9.8 into 1, 9.8 kg meter per second square or 9.8 Newton. 1 kg equal to 9.8 Newton. Similarly, 1 GF, the force of gravity acting on a body of mass 1 gram. Therefore, 1 GF is equal to 1 gram. If I change this 9.8 meter per second square into CGS unit, that become 980 cm per second square. 1 into 980, 980 gram cm per second square or 980 dyne. Now, here we see that 1 kgf is equal to 9.8 Newton, 1 gf is equal to 980 dyne, and 1 kgf equal to 1000 gf. Now, we know that how the momentum, change in momentum related with force applied. This is given by Newton's second law of motion. And what is the SI unit of force, CGS unit of force, gravitational SI unit of force, and gravitational CGS unit of force, and the relation between them. Also, we know what is momentum, how is momentum is measured, whether momentum is vector quantity or scalar quantity. It is vector quantity. These things we discuss in this video. We will discuss the impulse and Newton's third law of motion in my next upcoming videos. And if you like my video, you share, subscribe and like it. And if you subscribe my channel more and more, then I will encourage it and I will upload more and more videos. That's which will benefit for you. Thank you.